All right. Good evening, everyone. Hello. Am I audible to all of you? Good evening, everyone. Good evening, Kalpu Magical World. That's a strange name, Magical World, huh? Hi, this is Abhishek. I welcome all of you. Am I audible to all of you? Will you be kind in, right? Will you be kind enough to type in the chat and let me know whether I'm audible to you or not? Hello, Mrinal Mrinal Mahapatra. Welcome. We will wait for a few minutes till other students join. All right, then we will start. Hello, Sanjana. Hello. Hello, Piyush. All right, so your name is Piyush. Great. All right, great. So as you know that we will be starting with ray optics. We will wait for a few minutes and then we'll proceed. So where are you from, Sanjana? Sanjana and Piyush. Where are you from? Tarun. Hello, Tarun. Good evening. May I know from which cities you guys belong? I'm just curious. That's it. Kalpu, Mrinal, Piyush, Sanjana, Tarun. No replies. Will you be kind enough to reply? I guess this session can be a lot more interesting if you guys are willing to reply. All right, Bihar. Great. Great, Piyush. Others? Telangana. Okay, great. I heard you. Piyush, I heard you the first time. Mrinal, Tarun, and all right, Sanjana, Vishakhapatnam. All right, great. I think I have been to Vishakhapatnam. No, it was Vijayawada. I have been to Vijayawada. All right, great. So let me give you a brief introduction about myself. I am Abhishek Mathur, and I'm a pass out from DTU. If you have heard of it, DTU earlier it used to go by the name of DCE, and I'm a engineer, mechanical engineer, passed out in 2016. And current, I've been working with one of the renowned brands in this coaching industry. I've been associated with Akash Institute for last 4 years. Can you hear me, everyone? All right, great, Piyush. Spani Shiva, welcome, welcome, everyone. All right, so I think we should start. So first of all, will you be kind enough to tell me about the quality of the broadcast? Am I audible to all of you and my video is clear to all of you? My video and audio is clear to everyone? All right, Tarun, great. Great, Tarun. All right, so how's your preparation going, everyone? Will you be kind enough to let me know how's your preparation going? I hope it's going amazing, everyone. All right, great, amazing. Kota Goda, amazing. Hindi, please. See, Piyush, there are a few students from South, so it won't be possible for me to use Hindi, even though I'm from Delhi, but I think that won't be possible for me, na? Because there are certain students who can't understand Hindi. So I will prefer to use English. All right, so Patel Om is saying that his preparation is going amazing. All right, great. Piyush is somewhat satisfied. Kalpu not well, sir. Good, sir. All right, great. So we will have a session of ray optics. We will start from the beginning and please interact so that. All right, Tejas, amazing, amazing. just let's interact that the session can be more interesting. Right, so this is a brief introduction about myself. uh, I love to teach, and especially physics, because I fell in love with this subject when I was in ninth standard. It was an amazing subject, and it still is. That's the reason why I'm still teaching this subject. Right, so I'm an engineer by choice, explorer by default. I love to explore. I want to interact with a lot many students. That's the reason why I joined this platform. Right, so and I really hope that me teaching here will be able to do some kind of change for you in your life. You might be able to. No, I'm so sorry. I think together we can improve your physics. We will definitely add on something to what you guys are already doing. All right, so this is a course you already know. You guys are already familiar with this. 90 plus classes, convenient educational platform, syllabus from JEE experts, and flipped classroom method. So let me emphasize on this flipped classroom method for some time. This flipped classroom method means that you guys will be provided with all the theoretical notes before the class, so that before the teacher starts teaching you, you guys have a brief idea about what you are going to learn, and the class can be a lot more convenient during that. And then we have doubt solving and practice sessions. You guys will be given questions, and you can try to solve those questions and clarify your doubts in the class itself. All right, so I think without further ado we should start with the lesson. What say, guys? Can we start? All right, my favorite physical science before entering into JEE. No, it's fine, it's not that tough. Don't worry about it, Kalpu. All right, so my screen is visible to all of you. Ray optics. Can we start, everyone? Right, so all right, great. Ray optics. See, the first thing which we should learn is the optics itself. What is optics? What is optics? See, optics is a branch of science which deals with the light. Okay, optics is the branch of science which deals with the light and the various phenomena shown by light. Right? Branch which deals with which deals with which deals with light and various effects. All right, various effects shown by light. Great. Now, when we talk about ray optics, what we do is we are confining ourselves towards the ray nature of the optics. In other chapters, you might have heard that there are certain effects which can be uh, understood with the help of ray optics, but there are certain effects which cannot be understood with the help of ray optics. For example, you guys might have heard about Young's double slit experiment and single slit experiment. Have you heard of it? Please reply. Have you heard of Young's double slit experiment, everyone? There are certain phenomena which cannot be understood by considering light as a ray, but there are certain phenomena which can. So, in this chapter, alright, so great Tejas, Tejas, great. In this chapter, we are confining ourselves towards the ray nature only. Okay? देखिए, light shows wave nature, wave nature, as well as particle nature, particle nature. Okay? In this chapter, in this specific chapter, in this chapter, light is considered light is considered as a ray. See, what happens is the wave we are talking about, the wave propagates something like this. So instead of this, what we do is we simply represent it like, oh, I'm so sorry. I'm sorry. So instead of this, what we do is we simply replace this by array. Understood? Because when we talk about a wave, there is no end to a wave. If this is source and wave is originated from this source, and if the wave is propagating in a straight line, instead of drawing this over and over again, what we do is we simply replace it by array. Is this clear to all of you? No, sir. Sir, Hindi. Kalpu, no, sir. Regarding what? Sanjana and Sarvani? Kalpu and Sanjana? May I know why you are saying no, sir? Is this clear to all of you? Is this clear to all of you, beta? All right, great. See, light is an electromagnetic wave. Light is a electromagnetic wave, and we also have a specific chapter. Yes, all right, got it, Kalpu. We have a specific chapter regarding electromagnetic waves. Um, I'm assuming that you guys know about it as well. So, if this is electromagnetic wave, let me change the color. Let me just draw the diagram. Oh, just a minute. How to do this? Right. So when we talk about when we talk about electromagnetic waves, see, I'm just trying to draw the diagram. Just give me a minute. In electromagnetic waves, what happens is we have electric field and magnetic field, which oscillate perpendicular to each other. The diagram can be drawn something like this. Can you see the diagram, everyone? Can you see the diagram, everyone? Language problems. क्या करूं सर मैं? दीपांकर सर. All right, so I will continue my lecture in English. See, this is electric field and magnetic field oscillating perpendicular to each other. The plane is perpendicular. All right, so I guess my diagram is not visible to you because of my camera. All right, so all right, it's not even much relevant. See, the only point which I was trying to make here is that electric field and magnetic field are perpendicular to each other. All right, so electric field and magnetic field are perpendicular to each other. I hope you guys know it, and even if you don't, it won't matter much in this chapter. See, when we talk about light, light is something which enables us to see. Light is a form of energy and it enables us to see. All right, so let me ask you a question, a very simple and interesting question. Suppose that we are in a situation where there is no light. We are in a deep forest where, and it's night, 12 o'clock of night, there is no light. What we can do is, will we will be able to talk to each other? or not at night? Will you please reply? At night, can we talk to each other? Uh, Lisha, I got your point. All right, so I will draw it again, just in case if you are having trouble. I didn't realize that the my video was blocking the diagram itself. The diagram was something like this. Because air exists. All right. See, we can talk at night because air exists. When we talk about sound, sound is a mechanical wave. It needs medium, and medium is present, so we can definitely talk at night. Great. But can we see each other at night? No, we can't. Can we see each other at night? No. Can we see each other at night? We cannot see each other at night. And the reason is, the reason is, see, we see each other because of two reasons. There are only two reasons that we can talk, because there is no vacuum. All right, great. Balance game. That's great. All right, so I'm just trying to draw this diagram again. No, sir. See, this diagram here represents perpendicular electric and magnetic field, which you might have already seen in EM waves chapter in your 12th standard. Have you seen this diagram? This diagram represents like perpendicular, perpendicular electric field vector and magnetic field vector. All right, now let's. All right, now let's. All right, great. That's great, Asif. Asif, that's great. See, the reason why we can see something, reason why we can we can see an object. The first reason is object is a source of light. The object itself is a source of light, and second is object 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 is reflecting the light. These two are the reasons why we can see an object, right? If we are talking about the situation when if we are talking about the situation when there is complete dark in the forest, there is no source of light, we won't be able to see each other. The reason why we are able to see each other is reflection. See, I'm not a source of light. When light is falling on me and that light is getting into this camera, and then you are able to see me, that's something which happens in our day-to-day life. We are able to see an object just because that object is reflecting light. If an object does not reflect light, we cannot see that object until and unless that object is the source of light itself. For example, uh, just to give you one more example, if I talk about two objects, let's take one example. Let's take one example. Which one? Which one? Which one will be visible in a dark room? A, a red shirt. B, red hot iron bar. Alright, so will you be kind enough to uh, tell me which of these two objects will be visible in a dark room and why? Please go ahead and try this. I know you can do this question. It's a pretty simple and conceptual question. Alright, great. I'm waiting for the replies. Please reply, everyone. See, before we go into all the difficult stuff now, this is something which needs to be clear. Alright. Please reply, everyone. Red hot iron B. Alright, great. Kalpu, Ashif, Sindhu. Great. I would like to request other students to please comment and write down the correct option out of A and B. Alright. See, alright, great. Great. The reason is the reason why red hot iron bar is visible because it's a source of light. You might have heard this. When we heat a iron rod, it absorbs energy, and when the electron gets excited and when it comes back to its ground state, it emits energy, it emits radiation. Yes, that's correct, Ashif, that's correct. Red hot iron bar iron bar will be visible as it is a source of light. I hope this is clear to all of you. All right. All right. So a few more basic things about light. See, when we talk about light, what we do is we talk about visible light. Visible light. Now, what is visible light? See, visible light is a portion of electromagnetic electromagnetic spectrum. I'm sure you must have heard of about X-rays, gamma rays, infrared rays, UV rays. Have you heard of it, everyone? Please let me know in the comment section. Have you heard of all these rays? You must have in your 12th standard. All right, great. Great. And visible light is simply a portion of that electromagnetic spectrum. So can anyone tell me what is the range of wavelength for visible light approximately? All right, great. Great. Risha, very good. Kalpu, very good. See, the range the range of wavelength the range of wavelength the range of wavelength is 400 nanometer to 700 nanometer. This is approx range. This is approx range. Is this clear to all of you? All right, great. Great, everyone. Thank you so much for your spontaneous and quick response, everyone. Great. So this is your visible light. When we talk about visible light, what are the various colors? This is Vibgyor. We all studied this in our all right, great. Great balance, game and Lisha. Great. So this is our Vibgyor. These are the various colors. So when we go in this direction, frequency decreases and wavelength increases. Wavelength increases, isn't it? Your wavelength of red is highest, and when we will go in this direction, when we will go in this direction, the frequency increases, isn't it? All right, great. Rainbow, Vibgyor. All right. So I don't know if you have heard of this or not. When we are heating a iron rod, when we heat a iron rod, it starts getting red, and if it is further heated beyond that, it starts getting blue. Do you know this, everyone? See, there are a few relations which you might have heard, that E equals to H nu. Have you heard of this? E equals to H nu. See, higher the frequency, higher is the energy. High frequency, high frequency means high energy. है ना? So the energy of which color is going to be highest? Red or violet? Red or violet? Energy should be highest for which color, beta? Red or violet? It should be highest for violet because its frequency is maximum. Alright? Alright, and there is one specific point which I would like to emphasize on. Note, note. See, when we talk about speed of a wave, it is given as lambda into frequency. It is given as lambda into frequency. And please note that color, please note that color is a property, color is the property of frequency. Color is the property of frequency. Color depends on frequency and frequency only. All right. The color of the color of the radiation depends on the frequency. So until and unless frequency is until and unless frequency is changed, the color will remain constant, or the color will remain same. Color will not change. Is this clear to all of you? Is this clear to all of you, beta? And and frequency 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 does not does not depend on medium, but it depends it depends on source. So here I can ask you a very simple question. I hope you guys understand this. Is this clear to each and every one of you? Do let me know, please. Asif, Kalpu, Tejas. Great. So if I have a container here, and there is some liquid filled here, and I have I have a bulb here, and the observer is outside. Observer is outside. It's a green color bulb. It's a green bulb, and the refractive index of refractive index of this liquid is given as 2, and it is asked what is what is the color of light seen by observer. Please go ahead and answer this simple question. Please go ahead and answer this simple question. What will be the color seen by the observer? Anyone? Come on, you can do this. So a simple question, everyone. You can do this definitely. Go ahead and solve this. Do let me know if you are facing any sort of difficulty in solving this question. Tejas, Kalpu, Asif, Sindhu. All right. Anyone else? Please try. So there's one thing which I would like to ask you. Do you guys really think that these will be the color, or you are just messing with me? Kalpu, Tejas, and Sindhu. Mixture. All right. Asif, mixture. You think it's going to be a mixture? Great. All right. So as I said, color is a property of frequency, and frequency does not depend on medium. Frequency does not depend on medium, so it doesn't matter which medium it is. It really doesn't matter which medium it is. See, the refractive index is simply given to confuse you. All right. So if it's a green bulb, it will emit green radiation or green light. So when green light will go from this medium to air, it doesn't change a thing. Everything will remain same. Is this clear to you, everyone? Please reply in the chat box. Please reply in the chat box. This question is simply based on this note, right? So the answer is going to be color is going to be green. Why it's green? Because frequency does not change when light goes from one medium to another, and color is something which depends on frequency. So the radiation will be green only. Should we proceed further, everyone? Should we proceed further? All right, great. Got it. It will be green. All right. All right, great. So there is one more question which I would like to ask you. If I say that I have two balloons, I have two balloons, I have two balloons, I have two balloons. This one is red, this one is blue. Don't go on the color which I'm using to write the name, all right? If it's blue, it doesn't matter in which color it's written, it's blue, all right? Or maybe I think I should use blue only. Just give me a minute. I hope it's fine now. And what we did is there was some incident radiation on both of them. Can you see it, everyone? This is blue light. This is again blue light. So which balloon which balloon will burst first? All right. Sorry. Oils. I oils. Tejas, what do you want to say? I'm unable to understand you, Tejas. Tejas. So please answer, which balloon will burst first, red one or blue one? Go ahead and please answer this question, everyone. Both don't burst. Cha, great. The blue one, right? Nothing, sir. Nothing will happen. Acha. See, there's one thing which I would like to emphasize on. Do you know why red balloon is red? Red balloon is red because it is reflecting red color. Red balloon is red because it is reflecting red color. Got it? And blue color balloon is blue because it is reflecting blue color. And when you are giving blue radiation to red and blue, what will happen? The red color is not going to reflect blue, it will absorb blue, because red color balloon reflects red light, it will absorb blue. Got it? And the blue color balloon is reflecting blue light, so it will reflect it. Got it? red balloon red balloon will absorb blue light, thus after some time thus after some time it will burst, it will burst. Whereas the blue balloon the blue balloon is reflecting reflecting incident, it is reflecting incident blue light. Got it? Then it must be red. Alright, great. Thus it will absorb less energy less energy compared to red, and will burst burst later. All right, I hope you guys understood this question. Is this clear to all of you, everyone? Is this clear to all of you? Kalpu, Ashif, Tejas, Jawahar, Govind, Raj. Yes, clear. All right, can we proceed further if this is clear to all of you? Great, great. So I think what we should do is we should proceed towards reflection now, because I hope these things are clear to all of you. Great. So what we can do is we can talk about reflection now. What is reflection? We can talk about reflection. What is reflection? We know what is reflection. Reflection is bouncing back of light. Reflection is bouncing back of light from an object. When light bounces back from an object, we say that reflection is happening. If we have a surface, if we have a surface, if we have a surface, light will light is incident on the surface and it will bounce back. It will bounce back. You can see that it will. I'm sorry, just give me a minute. Light will. What is happening? Light will bounce back. This is reflection. Let's see what are the laws of reflection. What are the laws of reflection? Laws of reflection. All right. So, what are laws of reflection? Can anyone help me out? Normal reflected reflection is when light bounces. Great, everyone. Tejas, very good. Kalpu, very good, beta. Laws of reflection. Let's talk about the first law. First law says that angle of incidence, angle of incidence, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. This is your first law of reflection, and the second law is incident ray, incident ray, reflected ray, reflected ray, and normal lie on same plane. Let me draw a diagram so that we can get a better understanding of this. These two laws. Do I have shapes here? How will it? Alright, so I don't have shapes here. Right, so I will try to draw the diagram. See, if you have any surface here, which is polished and and this is your incident ray, this is your incident ray, then this is your reflected ray, and let me draw the normal. This is normal. So please keep this in your mind that you have to always measure angle of incidence and angle of reflection from normal only. Please keep this in your mind always. All right, this is your reflected ray, reflected ray, this is your incident ray, incident ray, and this is your normal. Okay, this clear to all of you? Great, great. See, uh, angle of incidence, angle of incidence, angle of incidence, and and angle of reflection, angle of reflection are are always always measured, are always measured from normal. Please keep this in your mind. You might be tempted to use the angle which is given with the mirror. All right, so this might be the case somewhere where you are given a plain mirror and ray is given something like this, and ray is given something like this, and this angle is given in question. Can we say that this is your angle of incidence? No, we cannot, because it is not given with the normal. This angle is given with the mirror. Angle of incidence has to be given with the normal only. This has to be your angle of incidence, which is going to be 60 degrees. Is this clear to all of you? I hope this is clear to each and every one of you. Please, please reply in the chat box so that I can know whether you have understood this or not. Right? Kalpu, Tejas, Ashif. Right, great, great, beta. Now, there is one another way of writing the second law. The second law can be written as, can also be written as scalar triple product. This will be used very rarely. Scalar triple product, scalar triple product of incident of incident reflected and normal, and normal is 0. Got it? Let me write it mathematically. I hope you guys understand what is scalar triple product. This is there in 12th class mathematics. Do you know what is scalar triple product, everyone? So if I take a unit vector representing direction of incident ray, and if I take cross product of this unit vector with normal or reflected ray, then I take its dot product, this will be 0. This is what I mean when I say that scalar triple product of incident reflected normal is 0. See, these are unit vectors. I hope you guys are accustomed of using. No, I'm in 11th. Oh. Alright, so see, Kalpu, it won't be used much, so you don't have to worry about it. I just thought maybe I should write it down. That's it. Alright. So now let's move towards plane mirror. Let's discuss plane mirror now. It's time that we should discuss plane mirror. What is happening? I removed this ruler which I used. Done. Alright. So let's talk about plane mirror. Uh, but before talking about plane mirror, I think we should also discuss about the various types of objects and images which are formed, isn't it? Types of objects, types of objects, types of objects which we will be dealing with. Can you see my screen, everyone? Is this clear? When we talk about types of object, there will be two types of object. One is real object, the other one is virtual object, virtual object. When we talk about real object, there are two possibilities in real object. The first one is point object. Point object. See, when we talk about point object, beta, the size of the object is very small. It is point sized. What are the dimensions of a point? A point does not have any dimensions. Its size is so small that we don't specify its size. Are you getting me, everyone? Are you with me? Can you hear me, everyone? Object is object is point sized. Object is point size. And the second one is going to be extended object. The second one is going to be extended object. The second one is going to be extended object. Sorry. Okay, what is happening? Not writing. The second one is extended object. See, what do we mean by extended object? We mean that the size of the object has to be considered. Alright? Size of the object has to be considered. Size of the object, size of the object has to be considered. Is this clear to all of you, beta? Size of object has to be considered when we are talking about extended object. Now, the other type of object, alright, see there is one more way of representing a real object is that light rays which will be coming out of the real object will be diverging. It will be diverging. Let me draw it. If I draw a point object, if I draw a point object, the light rays which will be coming out will be like this, diverging. Something like this. Are you getting me? Diverging light rays. What are these? These are diverging light rays. Diverging light rays. And this is our point object. This is our point object. Is this clear to all of you, beta? This is our point object. Now, when we talk about virtual object, when we talk about virtual object, see we can understand virtual object very simply as point point where light rays were converging. That point where light rays wanted to get converged, but what we did, we placed some sort of mirror or lens in between, and now the light rays are not converging at that point. Are you getting me? For example, for example, for example, if I had this kind of a situation, these three light rays, these three light rays wanted to get converge at this particular point P. No, sir. No, Abhishek, real point object and extended object are two totally different object. Jawahar, see, this is something different. Don't mix it. All I'm trying to say is that when object is real, the light rays, diverging light rays will be formed. The light rays which are coming out of the object are diverging. Jawahar, have you got my point? Please confirm, Jawahar. All right. So as we can see that these light rays are converging light rays, converging light rays. They want to converge at this particular point, but what we will do is we will introduce a mirror or a lens or an object which will not allow these light rays to converge at this point, right? So if I place if I place a mirror in between, and I don't allow these light rays to meet at this point, you know what will happen? See, this is the point P. This is the point P where light rays were supposed to meet, right? This is the point where light rays were supposed to meet, but light rays cannot meet here. Why? Because they will get reflected. Are you getting my point? Everyone, is this clear to each and every one of you? In this case, this P will work as this P, this P will work, this is happening. This point P will work as, it will work as a virtual object. Is this clear to each and every one of you? When light rays want to get converged at a particular point, but you have placed some mirror or some lens in between, and the light rays are not able to converge at particular point, then the point where they were supposed to meet will work as a virtual object. Is this clear to each and every one of you? Please reply in the chat box. Everyone, please reply in the chat box. Is virtual object clear to you or not? Kalpu, Tejas, Jawahar. Virtual object is clear to you? Alright, great Kalpu, great. Tejas, is this clear to you? Alright, so this is the topic where we will end our today's discussion, and we will continue it in tomorrow's lecture. Right? In tomorrow's lecture, what we'll do is we will continue with the questions of plane mirror and a few concepts related to plane mirror. Today, what we had, it was a brief introduction about the chapter and plane mirror itself. We have discussed the different types of objects, and we will continue this in tomorrow's lecture. Right? So I hope I will see all of you tomorrow. Till then, take care. Have a good day. Be safe. Right? Take care. Good night, everyone. Good night.